Welcome back. This is Daniel Pinheiro from danielpm1982.com, and this is the second practice lecture about our second topic, XSD. Last practice lecture, we've seen all the XSD documents we've used at the first topic, XML, and now we're going to see all the subtopics we've seen on the second topic of our course. So initially, I'd like to show you regarding the general syntax of XSD, all three ways we have to write in XSD, all the three design methods we have, which are the simple method, the divided method, and the named types method. And for this, we're going to use a simple example, which is a shape order XSD document. And we'll write the same example context using the three forms we have. First, the simple method, and then the divided one, and lastly, the named types. And of course, later we'll test with some XML instances for each of these XSDs. So let's start creating an XSD document and use the simple method for writing it. So new, other, XML schema file, let's call it shape order simple method .xsd, maximize it, Ctrl+Shift+F, organize the attributes, okay, now let's start declaring all the elements. And as you remember, the main characteristic of the simple design method is that we have only one global element declaration, which is the root element, and all the other elements and types are set nested to it in the sequence of the tree structure that corresponds to that XSD structuring document. So the first thing is always to create the root element. Then to that root element, we set its complex type with all other elements inside. Okay, here inside this complex type declaration of the complex root element, we set a sequence, and initially we've declared two elements. One is a simple element of type string, which is the client or the client name, and the other is the shape2. It means the destiny for that order. And inside this complex inner element, shape2, we declare its complex type with a sequence of 6 simple elements, which are the name, the address, the email, the city, the state, and the country, all of them using simple types, in this case, string types. So inside the complex root element, you open a complex type and another indicator. In our case, it's the sequence indicator. And inside that sequence indicator, you can declare any other number of elements, simple elements or complex elements, and any number of levels inside. You can open a complex one, then another complex one, and so on. So as you see, depending on the complexity level, the code using the simple design method can get pretty chaotic. For example, if we had 5 or 10 levels of nesting elements, the code here would increase a lot and end up very difficult to maintain. So that's one of the disadvantages of this method. And the other is the impossibility of reusing any of the declared elements or types, because the only global element declared, and if you see, we do not also declare any attribute or type globally. The only global element declared is the root element, and it doesn't make any sense to reuse that root element. So in order to reuse any type or element, we would have to have those elements and types declared globally, which is not the case with this kind of design method. So even for similar types, you gotta create each element individually, and you can't refer to any other element or type previously declared globally, because there are no globally declared elements or types except the root element. So now let's declare the other elements for that root complex type. And lastly, outside the indicator, we declare the attribute. And that's it. So for this very simple shape order schema, and using the simple method, we have declared a root complex element called shape order. Inside its complex type, we've declared a sequence of 5 elements, some of them simple elements, some other complex elements as the shape2 and the item. Inside those complex elements, we've also declared their complex type with a sequence of other simpler elements, as the name, address, email, city, state, and country for shape2, and the title, quantity, and price for the item. And for the item complex element, we've set the max occurs indicator as unbounded, because we are required to add as many items as the client wants to add at that shape order. So the root element means the order itself, at most one order, and for that single order we've added these elements, simple and complex elements, including the item element with a max occurs unbounded. So we have the client, the shape2, the item, the discount ticket, and the date time. And lastly, we declare an attribute, order ID, of type string and of use required, which is the only attribute we declare for being used at that root element. So now let's declare this same example using the divided method and later the named types method, and at the end we'll test all 3 using some XML instances to check if our documents are not only well formed but also the instances are valid when put against their respective schemas. So now let's create the same example using the divided method. new other, let's call it shape order divided method. Maximize it, Ctrl Shift F, organize the attributes. And differently from the simple method, if you recall what we've discussed about the divided method at the general syntax part of our theory, you will remember that when using the divided method, the first and initial thing we have to do is to declare all global elements and attributes so that they can be referred from inside the more complex ones. So you can only refer to globally declared elements, and in the case of this design method, the way you have to refer to them is to declare every element and attribute globally and then refer to them using the ref attribute from inside the nested element declarations. So let's declare the simple elements and attributes first. And now, after declaring the simple elements and the attributes, let's declare the also globally declared complex elements and refer to that initial elements and attribute from inside their nested elements declaration using the ref attribute. And at the declaration of these elements nested to the complex ones, observe that we do not set any name or type. We only refer, using the ref attribute, to the globally declared respective element. For example, for the first simple element of this shape2 complex type, we just refer to the initially declared name simple element declared above. So let's declare the other ones. Okay, that's our first complex element declaration. And now let's declare the other complex elements, including the root element. So now we are declaring the last complex element, which is the root element for our instances that use this XSD. And the root element will always nest inside it all other complex elements, including all the nested simple and complex elements inside those more complex elements. So, in short, the root element nests inside itself all other declared elements of our document. So here, as you see, we've added all the simple and complex elements declared before, and we've also set the max occurs indicator for the item complex element as unbounded, as we are required to let any number of items to be added to each ship order instance. And lastly, we declare also outside the order indicator the attribute for this complex root element. And that's it. Here is our ship order XSD document declared using the divided design method. And now let's rewrite the same example using the named types design method. New, other, XML schema file, let's call it ship order named types method. Maximize it, Ctrl+Shift+F, and organize the attributes. As you remember, the named types design method has as its unique characteristic the fact that instead of the globally declared elements, we now have globally declared types, both simple and then complex types, as well as the attribute, which later are referred to the types with the type attribute and the attributes with the ref attribute from the elements declarations inside the complex types and from the root elements declaration, the root element being the only globally declared element we have. So we've seen it a lot in our theory lectures, so that I'll just implement here, and later we'll test all three XSD documents with some respective XML instances. And as these types will later have to be referred to, they are all named, and that's why this method is called named types, as we've also discussed before. And also, as you see, as you're declaring the types and not the elements, you have to declare the types kind of using that extended form for the simple elements declaration, but using only the types and later referring to the types from inside any simple elements declaration, and also using the restriction element inside or nested to the simple type declaration, as well as its base attribute with the data type itself. So you can't use, when choosing this method, the inline simple elements declaration. And also we'll already let these simple types in their generic form so that it can be reused from inside any simple element declaration that have similar types. And now the attribute. And now let's declare all the complex types, and pay attention that they are also not the complex elements yet. They are the complex types. And inside those complex types, we'll declare some elements that will refer their types using the type attribute to the previously declared simple types up here. For example, inside the complex type shape2 type, we start the sequence of elements declaration by declaring a simple element with a name and referring to a previously globally declared type using the type attribute, and in this case, the string type. So this string type, globally declared, is reused 7 times at the element declaration of the elements from this complex type shape2 type. In this example case, the string type is a very simple type, but you could, for example, have very complex types declared outside, so that by reusing them, you would save a lot of code when just referring to them from inside each same type element declaration. That's one of the biggest advantages of this design method, the reuse of types globally declared. So now let's declare the other complex types and later the complex root elements. So these are all our types, the simple types initially, then the attribute, and then the complex types, shape2 type, item type, and also a shape order type with all other types nested inside it, as well as the attribute. And lastly, we declare the only globally declared element, which is the root element. And set as its type the most complex type we've defined before. Okay, that's it. And now let's test all these 3 XSD documents with some respective XML document instances. So first, let's create an instance for the shapeholder simple method XSD document. So new, other, XML file, next, let's call it shapeholder simple method .xml. Next, create XML file from an XML schema file. Next, then select the simple method XSD. Next, finish. So here is the template that Eclipse generates, but let's organize things better here. Instead of these sample values or template values, let's paste some values I have already created. I guess we maybe forgot to declare the zip code at the XSD, so let's go back to the simple method XSD and declare the zip code. Save it. Now go back to the XML. Okay, now it validates. So, at this XML instance for our first XSD document, shapeholder simple method, as we've seen a lot, we first declare the default namespace associated to the XSI prefix. Then through the XSI prefix we set the schema location with the target namespace and the name for the XSD document we've created before. Then we define a custom local namespace whose URI is exactly the same as the target namespace, and we associate to a local prefix so that we can access through that prefix all the elements, types, and attributes from the target namespace. And then for our example, we set the order ID attribute, for example, to 100 value. And observe that in the case of the simple method, as we do not declare any attribute globally, or any types or any elements except the root element, we can't refer to the attribute using the prefix for the target namespace. For example, we can't, as we've usually done, we can't use the attribute by using the prefix for the target namespace because that attribute is not declared globally. So in the case of the simple method documents, when we create the XML instances, we gotta refer to the attributes without the prefix for the target namespace of that document, because we can only refer to attributes through the namespace when those attributes are declared globally. And in the case of the simple method, as we've seen, we do not declare any attribute globally. But differently on the other two design methods, as we declare the attributes globally on both, we then can, at their instances, use the prefix, for example, Daniel PM 1982, colon, the attribute. But not in the case of the XML instances for simple design method XSD documents. And here we have some sample data for the client name for the shape2 complex element with a name and address, an email, a city, state, country, and zip code. Observe that the types must match. For example, we can't have at the zip code a letter because we've set the zip code as positive integers. Then we use the complex element item with a title, a quantity, and a price. And observe the type for the price must be a decimal. The quantity must be a positive integer. It cannot have letters. And the title is a string. You can also observe that as we've been required to do so, and as we've set the item element as unbounded, we can have as many items as we want to declare or to use inside this one and only shape order. So this whole document instance is one single shape order, and at that shape order we can add as many items as we wanna request. So in this case, I've put as example 3 items, item 1, item 2, and item 3 with different values. And lastly, we use the discount ticket, for example, with a discount of 20%. Also, it's a string value, and the date time, which must be a valid date and time value. So this is our shape order, our XML instance that we now will validate against that shape order simple method XSD document. So click right button, validate, and it validates successfully. The validation completed with no errors or warnings, which means that not only the XSD document and this respective XML instance are well formed or syntactically right, but this instance also validates or complies with all the constraints or data types, elements, and attributes created or declared at that XSD document. So now let's create an instance for our shape order divided method. Click new, other, XML file, let's name it with the same name of the XSD document, but with an XML at the end. Next, create XML file from an XML schema document. Select the XSD. Select the root element. In our case, it's the shape order, because as we've declared all the elements globally, the IDE cannot know for sure which element would be the root element, so we set manually here the root element we want, in our case the shape order. Click finish, maximize it, Ctrl Shift F, organize the attributes. And as you can see here, differently from the instances to the XSDs written using the simple method, in which we can't use the target namespace along with the attributes because there are no attributes declared globally. In the case of the divided method, and also similarly in the case of the named types method, we have the attributes declared globally, so we can refer to them using the local prefix that links to the target namespace of our XSD. So in the case of this instance that uses a divided method XSD, we can use the attributes from the prefixes linked to the target namespace. And for the data, let's just paste some structure and data I've already created before. Okay, here is our XML instance for that shape order divided method XSD. And as you can see, we have the client, the shape2 complex element with the name, address, email, city, state, country, and zip code. We have the item used as many as you want, because we've set the item with a max occurs of unbounded, so you can add as many items as you want to this shape order, similarly to the other examples. And then we have the discount ticket and the date time, all pretty similar to the other XML instance, except the calling of the attribute. So for validating, right button, validate, and the validation completed with no errors or warnings when validated against the ship order divided method .xsd. And now let's create the last XML instance for the named types method XSD. New, other XML file, let's call it with the same name, .xml. Next, create XML file from an XML schema file. Next, select the XSD, named types method. Next, the root element in this case is correctly set, because when using named types we have only one globally declared element, which is obviously the root element. So here you have the root element correctly. Finish, maximize it, Ctrl+Shift+F. Okay, observe here also that as we have declared the order ID attribute globally at the XSD, we can also, as at our last instance example with the divided method instance, with the name types method instance, we can also use the prefix that links to the target namespace of the XSD, because the order ID, both at the divided method as at the named types method, is declared globally, and the only method on which it is not is the simple method, in which we have to declare it only with the attribute name. So for the shape order, we now set the order ID as a 20 value, and as the data, let's also paste some data I've already created before. Very similar to the last example, with a client, a shape2, an item, actually 3 items. Remember, we've set the item max occurs as unbounded, so we could add as many items as we wanted at each order, and also the discount ticket and the date time. So nothing new at this XML instance. The only difference to the last one is the XSD target namespace and the XSD file name. So let's validate it. Validate. Okay, the validation completed with no errors or warnings. So with this, we conclude the implementation of the 3 XSD documents for each of the design methods we have for writing XSD documents, and also the testing of these 3 instances. They are all well formed and also validates against their respective XSDs. Now let's leverage our shape order business context example in order to show you, with some minor modifications, the 7 possible indicators from the W3C default namespace. So let's create a 4th XSD document still relating to this shape order example and use all indicators at this XSD. So new, other, XML schema file. Next, let's call it shape order named types method indicators. Finish. Maximize it. Ctrl+Shift+F. Organize the schema attributes. And now, using the named types design method, let's implement a similar example, but now using all indicators, including the other 2 order indicators other than sequence, which are the all indicator and the choice indicator. So let's start implementing our simple types and next the attribute. So these are the simple types in their generic form that we're gonna need to set the type at our simple elements declaration inside the complex types. And the only difference until now is this Boolean type. Now let's declare the attributes, and as you see, I've added some other attributes instead of only 1. So that now we will have 6 attributes. So these are the attributes we're gonna use at our complex types. And another difference of this XSD document compared to the other 3 ones we've seen before is that instead of a root element that represents a single shape order, now we have an XSD document that represents a shape order list, and inside that list we'll have any number of orders, and inside that orders we'll have all these elements nested to each order and each order to the list. So that's why now we're gonna have an order ID for each order, and we also have another list ID for the single order list, which will be the whole document. I've also added some example attributes as order paid, order processed, order shipped, and order delivered that represent the state of the processing of that shape order. And now let's declare the complex types. So this is our first complex type, which is similar to the same shape2 type we've used at our last example. But in this case, as you can see, the order indicator we used inside the complex type, shape2 type, is not the sequence, it is the access column all order indicator. And if you remember from our theory lecture about indicators, the all indicator specifies that the nested elements can appear at the instances in any order differently from the sequence according to which the elements must appear in one predefined order. With the all indicator, the ordering of the elements is not predefined, so you can use the elements nested to this complex type in any order you want, and the only constraint default to the all ordering indicator is that the elements as well as the whole set of elements must appear at most once at each XML instance. So the max occurs both for the whole set or for the all indicator itself is at most 1. We can't have a repetition of the whole set in one same instance. The whole set can appear only once for every instance, and each element itself can also appear at most once, and we cannot have any repetition of these elements either inside that set or inside the instance as a whole. So, for example, if we would set the max occurs, the only possible indicator both for the set or for the all element as for any of the individual elements would be a max occurs of 1. So if you use it either at the all element, any value greater than 1, you get an error. And also if you use it on any of the nested elements, any max occurs value greater than 1, you would also get an error, because either way you would have a possible repetition for the elements, either for the whole set or for that individual element inside a single set, and it's explicitly prohibited when using the all order indicator. So at most you can have a max occurs of 1, and as it's the default, we'll let it off from the individual elements, and just for us to remember it, I'll let the max occurs here at the all element explicitly set to 1, although it's also not necessary because it's the default. And the min occurs both for the all as well as for each of the elements can be, in both cases, 0 or optional, either for the whole set or for any individual element. So in our case, for the shape2 type, we'll not use an optional all indicator. We'll leave the default, which is also 1 for the min occurs. And for each specific element, we'll set the min occurs as it's here. For the first four, the name, address, email, and city, we'll set it as 1, as well as for the country. And for the state and for the zip code, just as an example, we'll set the miniatures to optional or to 0. So the usefulness of the all ordering indicator is to create a set on which no element, and not even the set as a whole, can be repeated inside the whole XML instance. Now let's declare the other complex types. Okay, this is the second complex type, and as you can see, it's an additional complex type I have created for this indicators XSD document to show you an example of another ordering indicator, which is the choice indicator. And as you remember, the choice, as the name suggests, is a choice between any of its nested elements exclusively, which means you cannot choose more than one on each choice. You can choose only one of the nested elements of that choice. For example, here, on each choice, you could only choose a priority mail express service type, or a priority mail, or a first class mail. You could not use more than one of these three elements at one same choice. And also for the choice itself, as you remember, you can have a mini occurs of 0 or more. In our case, we will let it optional with a mini occurs of 0 for the choice as a whole. And as max occurs, we could also have 0 or more. And in our case, we will let it only with a value of 1 for the max occurs, which means the instance would only be able to make one choice or to use one chance of choosing any of these three elements on each XML instance. So if we had more than one max occurs here at the choice, for example 5, at the XML instance, the user would have 5 chances to make 5 different choices, and he would then be able to choose more than one of these elements, of course, one at each chance or at each choice cycle. For example, at the first choice, he could choose this first service type. Then on the second, he would choose another one, and at a third chance, he would choose the first class mail, and so on. But in our case, we'll have only one chance, so that at most one of these three elements will be able to appear at each of our XML instances. Because in our case, it wouldn't make any sense of more than one choosing option for one same shape order. So this is the complex type that will be used at the service complex element declaration for each order of our order list. Each order of our list will have a service, and this service can have one of these three services, and all of them of Boolean type. Now let's declare another complex type. So this is the item complex type, which represents each item ordered at each shape order. And although similar to the other examples, we've used it for the shape order context. In this case, instead of sequence, we use the all ordering indicator. So the max occurs is always 1, both for the whole set, as for each element individually. I just use it, the max occurs here, as an example, but it's the default and it's the only possible value for the max occurs, so we could take it off, but I'll let it just as a remembers of the main constraint of the all order indicator, which is that the whole set and each individual element can only appear at the XML instance once. So we have for the item type an all order indicator with a min occurs of 1. It's not optional. You gotta set or use the item type to describe what item you're buying or requesting. And nested to that all indicator, we have 3 elements: the title, which is required, the min occurs equals 1, the quantity, which is also required, and the price of that item, which is optional. So this is the item complex type. And the next 3 elements are gonna be the 2 first, a group element, and the other an attribute group. So let's implement them. So in this first group, we are naming it client data group, and this group will be composed of 2 elements in a sequence ordering structure, which will be one of them a simple element of type string, which is the client name, and the other will be a complex element, the shape2 complex element, referring to the complex type shape2 type above declared, with the name, the address, the email, city, state, country, and zip code elements. So inside this group of elements, we'll have a sequence of actually 8 elements. The first of them a simple element, and the other 7 a set of complex elements. Now let's declare another group. In this second group will be the item data group, which will be composed of 3 elements that describe each item, which are the service of service type, the item of item type, both complex, and the discount ticket, which is of the simple type string type, and in the case of the item, with the max occurs unbounded. So at each order, nested to which these elements are going to be set, we'll be able, as on the last examples, to add any number of items inside each of the orders of that shape order list. And now let's declare the attribute group. Okay, for the attribute group, as we've discussed it on the theory lecture, you don't have to have any ordering indicator because it's not a group of elements. It's now a group of attributes that will be later set at our order complex type. So each of the orders of our order list will have all these attributes set to each order complex element. Observe that on the last two elements group, we've used the sequence order indicator, but at the attribute group, we didn't use any ordering indicator because now we are dealing only with attributes and not elements. And now let's declare the ship order type, which is the type that will be set to each of the ship orders, to each of the ship orders of our list. Okay, this is the ship order type, which will be set to each ship order element, and it's basically a sequence with the two element groups we've already implemented above, which means that at this sequence of this complex type, we are adding all the elements from both these groups, the client data elements as well as the item data elements. And we are also adding to the sequence a simple element, which is the date time element of the date time type. And at the group declaration, observe that we also do not define any name or type. We just refer to the previously declared groups outside, and automatically all the elements as well as their respective names and types will be added all together at this complex sequence. So for this complex type, ship order type, we will also add all the attributes ship order attributes group. So for that, you just create another attribute group and refer to the attribute group above, similar to the case of the groups. So at this complex type, we are adding all the elements from the groups, as well as an element alone from outside those groups. And we are also adding a whole attribute group, which is the ship order attributes group defined above. And all these elements and all these attributes are being nested to the ship order type. So now let's create the ship order list complex type. Okay, now we finished our XSD with the declaration of the shape order list type, which is a sequence of only one element, and this one only element is the shape order element, and the type for the shape order is the shape order type we've defined above. And also, as you see, the max occurs for this sequence as a whole is set as unbounded, so that we can repeat this sequence to add any number of shape orders to our shape order list type. And then we define the shape order list type as the type of our root element, which in this case of this Indicators XSD document example is not the shape order anymore. It is a list of unbounded shape orders, and for each shape order we're gonna have all the elements and attributes defined at the shape order type through the use of the groups and the attribute group, and also the individual elements defined above. So that's it. As you see on this example, we've demonstrated the use of all 7 indicators. First, the ordering indicators, which are the all, the choice, and the one we've used the most, the sequence. And we've also demonstrated the occurrency indicators, max occurs and min occurs, as we've already done many times before. And lastly, we've demonstrated the group for grouping elements, and also the attributes group for grouping attributes, both of which are grouping indicators. Okay, now we finished our XSD document indicators example, and now we only have to test it by creating an XML instance and referring that XML instance to the document. So click New, Other, XML file, name it with the same name of the document .xml. Click Next, create from the schema. Next, select the schema. Next, the root element, the only globally declared element, which is the shape order list. Then finish, maximize it, Ctrl+Shift+F, and organize the schema attributes. Let's set the order list ID to 50. Observe that the whole XML instance is a list of orders. And now let's declare some shape orders to our list. So I'll just paste some values I've already created before. Okay, so basically the values I've added correspond to two shape orders that I'm adding to this shape order list. These are the two shape orders. Remember, we've set the shape order element as unbounded inside the declaration of the shape order list. So we can add as much shape orders as we want now, and the whole instance will be a list of those shape orders. So this is the first shape order we are creating, and also see that we are using at this first shape order all the attributes from that attribute group: the order ID, the order processed, the order paid, the order shipped, and the order delivered. For example, for the ship order, we've set the order ID equals to 505, the order processed equals true, which would mean that the order would already have been processed, the order paid also as true, the order shipped as true, and the only remaining thing would be the delivered, because the order delivered would be false at this state of our instance. So most of these elements and attributes would be set by the system, not by any final user. So for example, if you requested from a server the shape order list or the shape orders, it would generate an instance, an XML instance with all these elements and attributes. And for example, for a certain stage of the processing, it would set these attribute values for a specific shape order, as we've exemplified here. So these values would change over time. And in the case of these attributes, which are Boolean attributes, it would change over time from a false to a true value until the recipient received and the process concluded. Then all these attributes would be true and the shape order would be finally delivered to the destiny. So this is the first shape order with some simple values for the client, for the shape to, with the name, address, email, city, state, country, and zip code of the destiny recipient. The service with one of those three options. In this case, the option chosen would have been the first class email, which is the only one set as true. The item or the items requested at that shape order, as well as the discount ticket and the date time for that shape order. And other than this first shape order, we also added a second one with different values, but basically with the same structure. So now let's test this order list instance to see if it validates against our XSD document, and it does. The validation completed with no errors or warnings, which means both the XML as the XSD are well formed, and also that this XML instance complies or validates against the shape order named types, method, indicators, XSD document. So this is it for the indicators example, as well as for the ship order example context. So we've seen so far some XSD document examples regarding the general syntax of XSDs, including the three design methods, the simple type, divided method, and the named types. Then we started exemplifying the XSD documents regarding the specific syntax with the declaration of simple elements, both the inline declaration as the extended declaration for the simple types, and also the declaration of the attributes and complex types as well. And we also exemplified with the last XSD example how to use each of the 7 indicators when defining complex types or complex elements. And now we will continue at these specific syntax subtopics, seeing now the extension and restriction elements. So first, let's use a pre-created XSD document called complex type extension. You already know how to create. It's just a simple XSD document that we're gonna use to exemplify how to use base complex types in order to extend these base types into other more complex types. Initially, this example is basically the declaration of 2 simple types using the extended form with a restriction element. So the first type we declare here is a basic simple type of type string, a generic string type, and the second simple type is an email type with the restriction of base string and with some constraints or facets restricting further that string base type with a max length of value 50 with a white space collapse and with a pattern for validating the text for the email input. So nothing new so far, just a declaration of 2 simple types, one a generic string type and the other an email type, both of which we're gonna use at the complex type we're gonna define now. So let's create a base complex type which later we are gonna extend into a more complex type and finally set that extended complex type to a root element. So this is the first complex type, which I've named type base, because it's gonna be the complex type that we're gonna extend on this example. And this complex type is a very simple one with a sequence of only one element, which I named element A, and the type of that one simple element is the string type we've defined above. So now let's create another complex type through which we're gonna extend this initial complex type into a more complex one. Okay, so this is the second complex type, which is the extending type, the type that will extend the last complex type above. And for using the extension, we have two cases. One is if you're extending a simple type declared elsewhere, and the other is when you are extending another complex type into a more complex one. So in case you are extending a simple type inside your complex type, you have to use the element simple content inside or nested to your complex type. And in the second case, in which you intend to extend a complex type into a more complex one, you use the complex content. So the complex type element will accept as nested element both a simple content or a complex content. The simple one is to extend a simple type, and the complex content is to extend another complex type, which is our case here. So we're gonna extend this complex type, the type base complex type, into another one. So we have to use nested to the complex type declaration of the second complex type, which is the type extended, the element complex content, and inside that element complex content you also use another new element here, which is the extension. And for that extension you set the base of the base type you're extending. In our case it's a complex one. If it were the case you were extending a simple type through a simple content, you would use the extension with a base of a base simple type. But in our case, the extension will have the base of another complex type, which is the type base. And inside the extension, we add the new elements and or attribute we're using to extend that base type. And as we've discussed in the theory lecture, we do not repeat the elements or the attributes that exist on that base type. So for example, in our case, our base type has one element, element A, and we wish to extend it. So inside the extension of the complex extending type, we only use another indicator with the new elements, in our case an element B, and we do not repeat that element A of the base type because it's gonna be implicitly added. We only declare the new ones. So we declare here the new element, which is the element B of type email type, and the element A of string type will automatically or implicitly be added together. So at this extending complex type, we'll have the element A of string type from the base complex type, and we'll now have as an extension the element B of the email type. And here, as we had not added any element on the base type, we can add an attribute at the extending type of name ID and of type string type with the user required. So with this complex type declaration, we'll have an element A, an element B, and an attribute. So the extension will be regarding basically the element B and the attribute, both of which did not exist on our base type. And then we just set, in our example, the extended type to our root element. And then we may test this document with a sample XML instance. So for creating the XML instance, new, other, XML file, let's call it complex type extension.xml. Next, create XML file from an XML schema file. Select the schema file. The root element is okay. There's only one possible element. And click finish. maximize it, organize the attributes of the root element. If you remember, for us to use the prefix here for the attribute of the root element, for example with a value of 10, we would have to have declared this attribute globally so that we could call it from the prefix that links to the target namespace of the XSD. And in this case we did it. So let's just go back to the XSD and declare that attribute globally. We are using the named type, so we should declare the attribute globally and then refer to that attribute from where we wanted to nest it or to set it. In our case, inside the extending or the extended complex type. So with the ref attribute, we then refer to the now globally declared ID attribute. And so we can go back to the XML instance and use that attribute through the custom prefix that links to that target namespace of that XSD document. So nothing new with that. The new thing is just to test the root element with that extended complex type, which would have not only this attribute as the extension, but also the element B as well as the element A, which is part of the base complex type we extended into a new extended complex type. So at the extended type, we should have an element A, an element B, and the attribute ID. And for the element A, it's in string type. You can type anything here. But the element B, it's an email type. So you gotta input some valid string that validates as an email. And that's it. Let's validate this XML instance against that complex type extension.xsd document, and it validates successfully. The validation completed with no errors or warnings. So with this, we tested the extension. We use it at the XSD document for extending a base complex type into another extended complex type using the complex content, the extension with the base of that base complex type, with the extensions for that base complex type, in our case, an additional element of different type, and an attribute. So that's pretty simple to extend both simple types as complex types using inside any complex type the access column simple content if it's the case of the extension of a simple type, or a complex content when you're extending another complex type. And inside the simple content or complex content using an extension element with the base of the type you are extending and the extensions. And the last thing I'd like to show you here is that you can use a simple content and complex content inside or nested to a complex type, but you can't use, for example, a simple content inside the simple type, any simple type. For example, if you use here and press Ctrl space, there's no option for using simple contents inside a simple type. So simple types do not have even simple contents, you can do a restriction. We'll talk about it on the next example, but you can't use the extension element or the simple content or complex contents inside a simple type. So you can only do an extension and use the simple content or the complex content inside a complex type. And the reason of it, as you can imagine, is just because when you extend some type, a simple type, you add either an element or an attribute or both, and you can't have any of these inside a simple type. Either if you add an element or if you add an attribute, that type will already have turned into a complex type, so it would not make any sense to have the possibility of adding a complex content or even a simple content with an extension inside a simple type. So if you wanna do any extension, you gotta use a simple or complex content inside a complex type and not inside a simple one. For extension, that's it. Now let's create an example about restriction. Okay, for the exemplification of a restriction of a complex type, I'll also do the same as with the last example. I'll use a pre-created file or document I've already created and called complex type restriction. And at this XSD, you also see that we only have two basic simple types. And firstly, I'd like to show you an example of restriction inside a simple type, because differently from the extension, you can do a restriction inside a simple type, and actually we have done it a lot. For example, when declaring a simple element, we've seen that we have two ways of doing so. We can declare the simple element in a inline form, just with the type attribute, and we can declare that same simple element using the extended form. And for the extended form, we nest to the simple elements declaration the simple type, and inside the simple type we add the restriction element, as here, with a base of any base type we want from the default namespace of W3C. In this case, for example, we are setting the base of the restriction of that simple type as access column string. So we've done it a lot before, and the new thing here is that we can not only do this restriction inside a simple type for W3C base types, but also for derived types we create ourselves. So we first created this derived type, string type, from the base string using the restriction, and then we are creating another simple type with the name string restrictor type, also using the restriction element, but in this case using as the value for the base not a default W3C namespace base type, but the derived type we've used above, the string type, and even using a constraint or facets inside as the max length and the white space. So we used the restriction both here for a base data type from W3C, and we've also used the restriction also inside a simple type, but in this second case for a derived base type. So despite the fact that we can't have the simple content inside the simple type, we can use the restriction element with both a base type or with a derived type inside the simple type. So for demonstrating the restriction inside a simple type, that's basically it. But in this example, we also wanted to show you how to use the restriction for complex types. So now we'll create a base complex type, and later we'll create another complex type, a restricting complex type, on which we are gonna use as the base type the first complex type, and then do a restriction on that base type to create a more restrictor complex type, as we've done for the simple type here. This second simple type is more restricted as this first one. So now we will show you how to use that same restriction technique for complex types. So we first create a base complex type, and then we restrict even more that first complex type to another more restricted one. So let's create the first complex type. So this is the first complex type we'll use as a base type, and we'll restrict even more this complex type into a new one. And as you observe here, we have two things nested or defined or set into this first complex type base, which is an element A of type string type, which is this type declared above, and we also have an attribute of the same string type declared initially at our XSD. So now let's create the other or the second complex type, which is the restricting complex type. Okay, we finished. So let me explain you this second complex type, which is the restricting one that I've called type restricted. And similar to the extension example, we use the complex content in the case that we want to restrict another complex type, or we also can use a simple content inside the complex type for restricting simple types. But in our case, we are restricting the first complex type, so we gotta use the complex content, and inside the complex content we nest the restriction element, and we set the base of that restriction as the type we want to restrict, in our case the complex type base. And differently from the extension case, in the case of the restriction, we gotta repeat every single element of the base type we are restricting at the current complex type. For example, here we had already declared the element A at our base type with a string type, but at the restricting complex type we also gotta repeat that same element A as here, because we wanna set another type now, a more restricted one. So we repeat the element declaration and set another type which must be derived from the type of the element at the base type. So at the base type we have the type string type for the element A, And at the restricting complex type, we redeclare that element A, setting a derived type of the string type, which is the string restrictor type. If you see above, we declare the string type here, and later we declare the string restrictor type, having as base of that restriction the first simple type or the string type. So anywhere at the code we can use those two types for restricting any other element, because the second one, the string restrictor type, will always be a derivation of the string type, and we can use that for redeclaring an element setting a more restricted type compared to the type at the base type we are restricting. So in short, here we have a complex type with an element A of string type and also an attribute ID also of the same type, string type. And at the restricting type, we redeclare both the elements as the attribute, setting as type for both a more restricted type derived from the first type we've used at the original declaration, both of the element A as of the attribute ID. So we restrict the element A and we also restrict the attribute ID using a more restricted type for both. And finally, we set this restricted complex type as the type of our root element. So now let's test creating an XML instance, new, other, XML file, complex type restriction.xml. Next, create XML file from the XML schema file. Select the schema. Next, finish, maximize it, Ctrl+Shift+F, adjust the attributes of the root element. And for using the root element attribute, as we've not declared it globally, we'll just use the ID alone with a simple value, and as you see, it validates successfully. But for testing the restrictions we've made, both for the ID attribute as for the element A, for the string type of both elements, let's test here with more than 10 chars. Okay, you see that the restriction worked, because we now can't have any string. We gotta have the most restricted string we set at the XSD, which has a max length of 10 chars. And the same for the element A. If you use until 10 chars, it validates, but if you add more than 10 chars, it does not validate anymore. So this means that the restriction we made on the second complex type, restricting the first complex type, worked, because we now have both for the ID as for the element A as type the more restricted string type we've set at the beginning of the XSD document. So that's it for the extension and restriction of simple and complex types. And now let's proceed with our specific syntax content by learning how to define a type or an element for having empty content or only text content or only element content without text, or in the fourth case, a mixed text and element content. And for that, we'll have to use both the extension as the restriction strategies.